the OCI block volume service. In this module, we'll introduce the block volume service and we'll talk a little bit about some of the inherent features. So what is the block volume service? Block volume service lets you store data on block volumes independently and beyond the lifespan of compute instances. And the key thing to highlight here is independently and beyond the lifespan of compute instances. And we'll look into that in greater details. Block volumes, as the name suggests, operates at the raw storage device level and manages data as a set of numbered fixed size blocks using common typical protocols, network storage protocols such as iSCSI. You can create, attach, connect, move volumes as needed to meet your storage and application requirement. Now, why would you use block volume? The first use case is sort of the most important one, and that's for providing persistent and durable storage. As you saw in the previous module, local storage is also sometimes called as ephemeral storage, is temporary. It lives and dies with the instance, and so it's not persistent, it's not durable. So if you have applications where you want to store the data durably, if you're running, let's say, a database, or you're running Exchange, SharePoint, these applications, VMware, you want that durability, so you would go with block volume. And then there are some other cases like expanding instance storage, instance scaling, etc. But the most important one and the most relevant one why customers would use block volume is for the persistent store and the durability of the data. Now there are some characteristics of the block volume you should know. First is the size. We support anywhere from 50 gigs all the way to volumes which are which can be 32 terabytes in size. That's pretty massive size. The disk type is, as we said, is NVMe SSD based, and the IOPS, input output per second, the IOPS performance, it varies. It goes all the way from 2 IOPS per gig all the way to 75 IOPS per gig. And you can see the IOPS per volume. We support up to 35,000 IOPS per volume, and we'll look into these in greater details. Some things are interesting here. You could literally attach 32 volumes per instance, which would give you a 1 petabyte storage space. So 32 terabyte per volume into 32 volumes per instance, nearly you are reaching a petabyte of storage. That's mind-boggling given the amount of storage you can use. And then you can see some of the things around security. Data is encrypted at rest. You could bring in your own keys, otherwise you could use the keys provided by us, and you can also do in transit encryption. Now there is new thing which we introduced recently, which is the performance tiers, and there is this characteristic called volume performance unit, or VPU. So what does that mean? Basically, what we are giving here is different performance levels. So starting with, if you there are three levels. So there is a lowest cost, there is a balanced tier, and then there is a higher performance tier. So what do these tiers mean? The balanced tier is the default tier you get if you create a new block volume or a boot volume. You get this balanced tier. This is what the block volume used to be in the past. You get 60 IOPS per gig, all the way to 25,000 IOPS per volume. Maximum IOPS per volume you get to 25,000. If you want to go higher than that, you probably have big databases you are running. You want the best possible performance. You could go with a higher performance tier that would give you 75 IOPS per gig, all the way to 35,000 IOPS per volume. And right here, you can see some of the numbers. The maximum IOPS per volume is 35,000, IOPS per gig is 75. If you don't need that kind of performance, you could go with a lower cost tier. In this tier, you get 2 IOPS per gig, all the way to 3,000 IOPS per volume. The important things to keep in mind: this tier is not available for boot volumes, because as you can imagine, you are booting up the volumes, you need higher performance. So that's why we start with balanced, but you could always go with higher performance for boot as well. And then the second thing is, there is no separate volume performance unit charge there if you go with the lowest tier. If you go with a balanced or higher performance, you have to buy uh, a specific number of volume performance units. So in case of balanced, you buy 10 VPUs per gig per month. In case of higher performance, you buy 20 VPUs per gig per month. All right, so having looked at the block volume elastic performance and the concept of volume performance unit VPUs, let's jump into some of the operations you can perform with block volumes. As you can see on the screen, and I'll bring up a demo and we'll get into more details there. You could create, attach a block volume, right? And there are two different ways you could do that. One is by using something called iSCSI, and the other one is using this mechanism called paravirtualized. Now, paravirtualization is a light virtualization technique where the VM utilizes hypervisor APIs to access remote storage directly as if it were a local device. iSCSI, on the other hand, utilizes the internal storage stack in the guest operating system and network hardware virtualization to access block volumes. So, in this case, iSCSI case, a hypervisor is not involved in the iSCSI attachment process. So, as you can guess, it gives you better performance, but you have to do a little bit more work in order to attach the block volumes to the instance, right? And we'll look into this in more detail as we go into the demo. You could detach and delete block volumes, and that's the reason people use block volume. It's persistent, it's durable. If you don't need it, your instance dies, you can still have it. You can still keep your block volumes. You can detach. You can attach it to another instance, and you so on and so forth, right? You can delete and all that. And we'll look into these in more details. Now, one thing to keep in mind, today block volume service supports this capability called offline resize. So what do we mean by offline resize? What we mean is if you want to expand an existing volume, you cannot just do a dynamic resizing where you go from, let's say, 50 gig to 100 gig. What you have to do is this thing called offline resize. So you have to detach the volume first if it's attached to an instance, and then you can change the size. So that's one way to do it, right? The other way is you can use volume backup, and you could back up to a larger volume, or you could do clone, and again you could go with a larger volume. When you do backup and clone, you're not restricted to do backup and clone uh, as the same size as the original volume. You can actually go higher, right? So again, we'll look into these in subsequent modules, but just keep in mind offline resize and various mechanisms you can use to change the size of the disks. Now also keep in mind you can only increase the size of your volume. You cannot decrease the size of the volume, which seems logical, but just yeah, keep that in mind. So with that, let me quickly jump to the console and show you a couple of quick demos. So right here you can see we have